Okay, welcome to trigonometry class. I learned how to do this process online, so I hope everything works out okay. I'm dealing with a new background because life's feeling really boring right now, and I wanted to include some color and variety. If you don't like it, say so now and I'll change it. Nobody? Wow, I thought Kevin for sure. All right, I'll keep it. Okay, so this lesson is dealing with sine, cosine, and tangent of values that we don't have on the unit circle, but we're expected to know them without a calculator. So let's take a look at our unit circle, the trigonometric values that we do know. We know 30 degrees and all the scalars of 30 degrees. And of course we tweak the positive and negative signs, but the numbers are the same after 90 degrees. Then we've got 45 degrees and all the scalars for that. These, maybe you guys have been off enough that this is starting to be foggy for you, but you can use your unit circles. Don't use your calculators except as a check. So, could we use our unit circles to calculate other values? For instance, 70 degrees isn't on there, so something like that. Well, the answer is yes. Consider taking the cosine of 15 degrees. It's not on our unit circle. However, we do know cosine of 45 and cosine of 30, and if you look close, cosine of 45 minus cosine of 30 is cosine of 15. So, this whole section deals with taking a number and turning it into a combination of one of our scalars that we already know. Let's take a look and see what that looks like. All right, so if cosine of 15 degrees is the same as cosine of 45 minus 30, we have a set of formulas from the book. These are the cosine sum and difference formulas. So you can see that in number 1, it's theta and omega added, and in equation number 2, it's theta minus omega. And you just write down these formulas in your notes and use these. Eventually they will become second nature. Okay, so clearly we're dealing with a difference, not a sum. So cosine of 45 and 30 become theta and omega. And notice that in your equations, those stay the same. They stay in the same order, right? 45/30 in the first part, 45/30 in the second part. Now, we know cosine of 45. We know cosine of 30. We know sine of 45 and sine of 30. So if you multiply both sets, you're going to get that on the left and that on the right. Same common denominator, so you just add them together. And that is the form that I want them for the homework. Don't give me no decimal crap. Shelby, I'm looking your way. Keep these as fractions. Keep the radicals in them. All right, so that's how it works for cosine. You would write your final answer that way. There's another set of formulas for the sum and difference of sine. They're not much different. They look like that. So how would we get 75 out of the things that we know? Well, we know 45 and we know 30. So looking at the sine formulas, we're adding, so we'd use the sum, that's number 3. So we're going to set it up as sine of theta and cosine of omega. Make sure you're subbing the right degrees in. And then from there, we know sine of 45, we know cosine of 30, cosine of 45, and sine of 30. Multiply the left, multiply the right, add them together. And yeah, this answer looks exactly the same as the last one, because on the other one we were 15 degrees up from the x-axis, and on this one we're 15 degrees down from the y-axis. Symmetry, baby. It's beautiful. Okay, so this is how it works for degrees. It also works for radians. So if we remember our radians that match the scalars of 30 and our radians that match the scalars of 45, we've got these. So something like sine of pi over 12 could be reduced to sine of pi over 3 minus pi over 4. You could take cosine of 7 pi over 12, and it's pi over 3 plus pi over 4. So the radians, it'll be the usual headache to convert, but other than that, it's exactly the same process. This stuff isn't bad, and just what I've shown you here will get you through 40. It gets a little trickier. There's some tangents, so you got to set up sine over cosine and then run sum and difference formulas in the numerator and then again in the denominator. But I don't feel too bad because you guys have had 5 weeks now or something like that on this assignment. You've got until the 22nd. FaceTime me, Zoom me, email me, step out on your front porch and scream. I can tell a math scream from others. I'll come running. Get a hold of me. You guys are the ones I really want to hear from anyway. I don't want our senior year to end like this, so let's communicate a bit, even if it's grinding out some brutal problems.